Let's do one more summation problem. Use the identity 1 over k minus 1 over k plus 1 is 1 over k plus 1 to find a simple expression for summation 1 over k plus 1. So we're going to start by using our identity. Our identity helps us replace this part inside here. We can replace it by 1 over k minus 1 over k plus 1. And now let's write out the expanded form of this here. 1 over 1 minus 1 over 1/2. That's what I get when I plug in k equals 1. Now plug in k equals 2, 1/2 minus 1/3. And if you notice, you'll see the negative 1/2 and positive 1/2 cancel. And the next term will be 1/3 minus 1/4. The negative 1/3 and the positive 1/3 cancel. Keep going. And the term before the last one is 1 over n minus 1 minus 1 over n. 1 over n minus 1 over n plus 1. So this negative 1/4 would have got canceled with the next term. The same thing with this minus 1 over n minus 1. And then these get canceled. And so I'm left with 1 minus 1 over n plus 1. And that's my nice simple expression for that. All right, so then we're going to talk about product notation. It's very similar to summation notation. I'm going to use a big pi symbol for product. You still have like a lower limit and an upper limit. And here it just means you multiply instead of adding. So all of these are being multiplied together. Now let's compute some products. Compute the following. A product from k equals 1 to 5 of k. So you plug in, again, start lower limit. You start from 1 and you end at 5. And you plug it into the formula. So 1 times 2 times 3 times 4 times 5, which is 120. Let's do one more of these. A product from k equals 1 to 1, k over k plus 1. So here I start at 1 and I end at 1. So there's just one number you're plugging in. You're not actually multiplying anything. 1 over 1 plus 1, or 1/2. So we've observed a few properties of summations and products that I want to mention. So the first one, if you have the same lower and upper bound on a sum, you can combine them into a single summation. Essentially, all you're doing is reordering the addition that's going on, and addition is cumulative. You can add in any order you want. If you have a constant times a summation, you can essentially distribute that constant, that coefficient out to all of the terms in the summation. And the third one, if you have a product, times another product, you can rewrite it with a single product. Just like you could write a single sum on the first property. All right, so let's look at some of these. Write the following as a single summation or product. A sum from k equals m to n, k plus 1 plus 2 times k equals m to n, k minus 1. So the first thing I'm going to do is I see this coefficient here. Using our second property, we can pull that coefficient in. To the inside, 2 times k minus 1. And now these summations have the same lower and upper bound, so we can use that first property to rewrite them as a single summation. And if you want to, you could simplify the inside. It would be 3k minus 1. If you distribute that 2. Let's do one more. Product from k equals m to n of k plus 1 times the product from k equals m to n, k minus 1. Because, again, these have the same lower and upper bounds, we can combine them using that third property into a single product. And if you want to, you can multiply the insides together. Just to simplify it, it would be k squared minus 1. And there's my single product. All right, so now let's talk about how to change a variable on a sum or product, change of variable. So when k equals 1 to 3, k squared, it's 1 squared plus 2 squared plus 3 squared. And that's actually the same thing as the summation I equals 1 to 3, I squared. So we could say that these two summations are equal. And really, what have you done? You've changed your variable from k to I. You replace k by I. But sometimes the change of variable is a little bit more complicated than that. So let's look at another one. J equals 2 to 4. J minus 1 squared. So I could simplify the summation, 1 squared plus 2 squared plus 3 squared. This is also the same thing as k squared. And what kind of change of variable have I done? I've replaced j by k plus 1. So if you plug in j equals k plus 1 into the original sum here, the result would be the one that you get on the right.